Alright, so this is from TRO, page 119. This is chapter 3. And the topic is empirical. How do you spell empirical? Empirical formulas, which I think is section 3.8. It might be section 3.9. Alright, so question 61, which I've got pasted here on my whiteboard. Samples of several compounds are decomposed, and the masses of their constituent elements are listed here. All right. So in the first example, we've got silver and oxygen. All right. And I'm going to set this up as a table, as I always do. I encourage you to do the same thing. I've got mass, and we're going to be using formula weight to get moles, right? It's molar ratios. These are always dealing with molar ratios. Whoops, whoa. Just a second here, see if I can replace that. Okay, so the mass of silver is 1.651, and the mass of oxygen is 0.1224. All right, I'm going to look for the formula weight in my periodic table. I'm looking at the inside of my cover of my book. And the formula weight of silver is 107.87. You should pause the video and fill out this table if you know where I'm going with it. And the formula weight of oxygen is 16.00. So the moles then is 1.651 divided by 107.87 equals 0.01531 maybe. Okay. 0.1224 divided by 16 is equal to 0.00765. Okay. Now the way that I've done this in previous videos is I've said, all right, well, let's go n prime. And we divide all of these, because this is the moles, right? That's the total moles that we've got in this sample. That's how many moles we have in here. But now let's go and divide by everything by the smallest number. The smallest number, of course, I'm going to go with a different color so you can just to sort of accentuate what's going on here. Divided by black. This is going to be that divided by the smallest number. What's the smallest number of those two? It's 0.00765, right? 0.00765. All right, so n prime, this one's going to be 1 because that divided by that is 1. And then 0.01531 divided by 0.00765 is going to be 2. It comes out to 2.001307, which is clearly 2, right? So the empirical formula here is Ag2O1, which we leave out, right? We leave the 1 out. Really what we mean is Ag2O, and that's the empirical formula for silver. Now let's do the next one. Let me get rid of this and do the next one and say this is cobalt, arsenic, and oxygen. So we're gonna go cobalt. Oops, let's go with red again. Just to get your eyes used to looking at the same thing. Cobalt, arsenic, and oxygen. Setting up a table here. Mass, formula weight, and moles. Always looking for moles, of course. You know what this is? This is grams per mole, right? And this is grams. How many grams of cobalt is there? 0.672. How many of arsenic? 0.569. And of oxygen, it's 0.486. I hope to convince you that by laying out tables, I'm always doing, problems always end up looking the same. Do a lot of, I always know what path I'm going to go down, right? Less thinking to do, less ways I can make mistakes. All right, so what's going to go right here for cobalt? You should pause the video and finish this table if you can. 58.93. Arsenic is 74.92. 16.00. And the moles of cobalt is 0.672. Clear it a second here. 0.672 divided by 58.93 equals 0.02282. Okay. Arsenic is 0.569 divided by 74.92 equals 0.03041. Let's put 4 sig figs in each one. That ought to be enough. And then oxygen's 0.486 divided by 16.00. This comes out to be 0.03038. You can see these two are going to be the same, right? All right, so we divide everything by the smallest number, and it looks like the smallest number is 0.2282. I'm going to use n prime again. I'm going to do I'm going to divide all these by the smallest number, right? And the smallest number's here, 0.02282, 0.02282, 0.02282. Okay, this number goes to 1. 0.03041 divided by 0.02282 goes to 1.36. Ooh, that's ugly. 1.36. Let's go 4 sig figs. And then 0.03038 divided by 0.03038 divided by 0.02282 is equal to 1.33. 1.331. Okay, so you know what we do now, right? Now we take this, I'm going to go n double prime, and we take this fractional portion and we say, what fraction does that look like? Let me go back over here to black. What fraction does that look like? It looks like 1/3, doesn't it? Okay, so if I multiply everything times 3, then this will become 3. Let me go back to red. This will become 3. This will become 4. And this will become 4. You see it? Times 3 is equal to 3.994. 1.3. Sorry. 1.363 times 4 equals, or rather, I'm sorry, just a moment, please. 1.363 times 3 is equal to 4.089. Yeah, that's easy. Okay. So it turns out, indeed, it comes out to cobalt 3, arsenic 4, oxygen 4. And this is the empirical formula for cobalt. Okay, let's do the last one now. I think that I can't do any more. No, it won't let me do any more. So I have to erase all this now in order to do. You know what I'm going to do? I really do want to keep this clean. Where's my eraser? I only have so many pages. This is a free version of Sketchbook. It only gives me so many pages that I could make new pages on, so I gotta go here. All right, let's go here now. Now let's do the last one. And the last one is selenium and bromine. Right, so the reason why this is easier for me is because I recognize these. You'll have to look these up, right? Selenium and bromine, you have those on your periodic table, but you have to look them up. So it's a little bit uncomfortable. Why am I in red? So selenium and bromine. You should pause the video and finish this. Mass, formula, weight, and moles. We're always looking for a molar ratio. I don't think I could overemphasize that. Okay, the empirical formula is a molar ratio. So selenium is 1.443, bromine is 5.841, the formula weight of selenium is 78.97, and that of bromine is 79. Wow, these are close. 79.90. We could probably guess what this is going to be. That looks like 1.5 and 6. I bet it's 1 to 4. I bet it's 1 to 4. Let's divide these out now. 1.443. 0.443 divided by 78.97 equals 0.01827. And the next one is 5.841 divided by 5.841 divided by 79.90 equals 0.07310. Now, in order to get n prime, we divide all these by the smallest number. So I'm going to say, which of these is the smallest? Right? 0.01827 divided by 0.01827. And this goes to 4. Sure enough. That goes to 4 and that goes to 1 because that divided by itself is 1. And so I can see that my empirical formula for selenium Se and Br is that. This looks like it's a molecular compound. You should name this. What is the name of this? Name. Is it molecular or ionic? Right? Pause the video, make a guess, and then I'll tell you. Let me suppose that you've paused it, and I'm going to say that the name of it is going to be selenium tetrabromide. Okay, hope that video is helpful in terms of empirical formulas, and keep the questions coming.